This video is for people in phase 4. You're at home looking for the answers and I'm glad you found this video. Now for the stuff we're going to be covering in today's video: find the current taken from the supply, find the phase angle, and state whether the current is leading or lagging. Step 1. Find the current taken from the supply. Now, what if I asked you, what does that mean? So take these water pipes for example. Each lane is a resistor, capacitor, inductor, and water flows through these out. What we have on the left here is the water pipes. We have water coming down the pipes, all 3 lanes, they're all coming through. And this, when there's 3 lanes, there is pressure. Now, current is just the pressure of the water, but in electrical terms. And if you look over onto the right side, just think of them as pipes and there's water going through them. It's the exact same thing. These zigzag lines are to represent electricity, as the water in this version is current. So you have the resistor, the capacitor, and the inductor, not pushing water but pushing current. So think of these as pipes, and it is pushing it all the way through and out. Now, how do we actually solve this? Okay, I have to be completely honest, I forgot to click record and I'm after going through the inductive reactance part. Now, if you don't know how to do this, I have loads of videos on this. I will link it down below and you can find out how to solve the inductive reactance. But here's the inductive reactance formula and the capacitive reactance formula. Now, it is the easiest 2 marks in the world, just fill in the gaps. Now, as I've mentioned, I've already found XL, and now I'm just finding XC using them 2 formulas I've just shown the last slide. So we're just filling in the gaps. We have 50 Hertz in the diagram, and we have 40 microfarads on the capacitor. So we're just filling in the gaps. We have 1 over 2 multiplied by pi multiplied by 50 by 40 multiplied by 10 to the power of minus 6. Now that is what we put in because it's microfarads. So as you can see, I found XL with 27 ohms, and now XC is coming out to 79.5, so we're going to round that up to 80 ohms. Step 2. Find the phase angle. On the bottom left hand side of the screen, under the dotted line, you'll see parallel circuit formula, starting with IT. Right, so let's take that formula and put it onto our page. So we have IR squared plus brackets IL minus IC squared at the end. I have to do the square root as well, just hiding it in here. So you'll see at the bottom left of your formula that you have this. Now you might think, we don't have IR, we don't have IL, and we don't have IC, but that is up for us to find. So, and for us to find IR, we need to do V over R, because R in our diagram is 100 ohms, and it says we're given in the question 200 volts. So this is going to be 200 over 100, which is going to be 2 amps to be precise. Now if we're doing IL, don't use the henries on the diagram, use your XL, which is going to be 27 ohms, but you're going to put that under 200 volts. Now 200 over 27 in the calculator, if it would focus, 200 over 27, put the decimals, 7.4 amps. Okay, so for finding XC or IC, you guessed it, we're going to go to XC and we're going to put volts at 200 over 80 ohms. If I can hurry up, we get this on the calculator, we go 200 over 80 is decimals 2.5 amps. Now, finding that we found IR, IL, and IC, we can finally sub in to the formula that we've been looking for all this time. And once you get all the numbers, the calculator can do the rest. And if you get to this far in the question, you already have a lot of marks on the question. So if you're finding this handy, please let me know down below, and if there's anything you think I missed, please let me know, because no one comments on these videos, and if you comment, more than likely I'm going to make a video the next day and you'll know while you're in college. So we have 2 squared plus, in brackets, 7.4 minus 2.5 amps squared. Put this into the calculator. This will find IT, as we said in the formula. So into the calculator, 2 squared plus 7.4 minus 2.5 squared. That comes out to 5.29 amps. Step 3. State whether the current is leading or lagging. Right, so next step is to find the power factor. I already have a video on this, so I'm not going to show you how to do it in this video, but I will also link it down below after. So we have IR and we have IT now. This is what's going to give us the power factor. So we take IR, which is 2, and IT, which is 5.29, and we put them in the calculator. Okay, so if we put in the calculator 2 over 5.29, that comes out to 0.378, and we just throw it in. Next part is just finding the phase angle. Also have a video on this down below, so if you want to find that, it'll be there. It's just shift cosine on the calculator and you get the cosine minus 1 with brackets, and you throw 0.378 in there and you will come back with the degrees answer. So we go cosine minus 1 over 0.378, we get 68 degrees. Now of course we're in a parallel circuit, so where we label IL, IR and IC on the diagram is important. IC is always on the top for a parallel and IL is always on the bottom, with voltage on the right and IR in the middle. Okay, if we just fill in the numbers, we can just go find IC, go find it over here, which is 2.5 amps. We go IL, which is also over here, which is 7.4 amps, and then IR at the same place, which is 2 amps. We now take IC and IL from each other. Now obviously IL is a bigger number, so when we take them away, we know the arrow is going to be pointing downward to IL. I'll show you now. So as we can see, we have 7.4 minus 2.5. If we throw this into the calculator and go 7.4 minus, that's wrong, get rid of that, focus up camera, minus 2.5 into decimals, we have, you couldn't see that there, 2.96. Now we know, because there's 2.96 left over, we're going to be going downward because 7.4 is bigger than 2.5. That is why it's on the bottom part and not the top part. As you can see, 2.96 is the arrow and it is lagging the voltage. Now because it's lagging, because it's under, that means this is an inductive circuit because we are lagging the voltage. That will always be the case. And it will be leading if it's a capacitive circuit, even though it's not in this question. But I hope this helped. Please send this to someone that might need help. Also, I'm going to say it again, if you do need anything else from me, just type in the comments down below. I'll make it my mission to get it out to you as fast as possible. Thanks.